Good morning or good afternoon, depending on where you're joining us from, everyone. My name is Blona Dodi. I'm features editor at PV Magazine, and I'm delighted to welcome you along to this session exploring the increasingly important role of technology in solar plant operations and maintenance. Now, as we know, the PV industry is renowned for its competitiveness, driven by its focus on lowering energy costs and delivering clean energy, while at the same time maximizing project revenues and cutting CapEx and OpEx. So it makes sense that solar professionals are turning en masse to tools like artificial intelligence, automation, and other software services to streamline their operations. And as the industry keeps growing and more projects are added to the grid, we are seeing in real time the value that having technical tools function as a sort of intelligence layer for operations and maintenance can provide. So how can tools like digital twins, automated drone inspections using thermal thermography or electroluminescence testing, data analytics platforms, cybersecurity tools, machine learning algorithms, SCADA systems, web-based remote monitoring, how can these all help asset owners and O&M professionals to maximize their project's efficiency and value? Sorry, we're just technical difficulty here. Stay tuned and we'll delve into all of these topics and more. I'm delighted to say that we have a full rota of guests joining us today from some of Europe's biggest EPCs and IPPs to O&M software specialists and startups, and they're all leading the charge when it comes to developing emerging tools and creating standards which the entire industry can learn from. But first and foremost, however, a big part of figuring out technology's growing role in any industry is research and development. And so it's very important for us to contextualize all of this innovation and these questions that we're about to hear about and answer in a big picture format. And to help us do that, I'm delighted to welcome our first guest, and she is Hind Abdullah, researcher at Khalifa University in the United Arab Emirates. Hello, Hind, you're very welcome today.
Hello, thank you for having me today. I'm really excited to participate and joining from United Arab Emirates.
Thank you, Hind. Thanks for joining us. We really appreciate it. So you've done a lot of research. You've read a lot of papers on operations and maintenance and solar, and you've quantified them all and done a wide analysis of a lot of industry research and papers. And basically, in your research, you've written that there tends to be a kind of an install and forget mentality among many in the solar industry when it comes to operation maintenance. What did you mean by that?
Okay, so when I talked about the install and forget mentality, I was actually referring to a pattern that we saw repeatedly in the literature and also in the industry. So the focus was on rapidly deploying plants. And once these plants started producing energy, maintenance was perceived as something to minimize rather than like a proactive or a strategic activity. And because PV systems have relatively simple design, so there was a misconception that they would require minimal maintenance. But and of course, this is really not a negligence, but I would say it's overconfidence in component reliability and also very competitive pricing structures that made the operation and maintenance budget limited. But I think that this is currently changing. So as the PV capacity is expanding, I believe that now there has been more investment in condition monitoring systems, UAV-based inspections, thermography, AI-based diagnostic, and operators are now realizing the value of or the cost of under-maintaining PV assets like higher degradation, performance losses, or missed revenue. So I would say that this is now changing. So the industry is moving from the install and forget mentality to install and continuously maintain.
That's good to hear, Hind. I suppose that things are changing, and there was a bit of a culture of complacency, as you were saying. And just to say to you all watching at home or in the office or wherever you are, that you can send in your questions to Hind and to all of the other guests today using our chat function on Big Marker, which is our webinar platform. So you can just feed them in as you have them, feed them in live, because it's a live event. We'll keep chatting to Hind anyway. So yes, Hind, I want to kind of move to, so you noted a very interesting pattern as well in the paper, that operations and maintenance in wind and the hydro industry is much more advanced than solar. Is there something that the solar community can learn from these other industries, do you think?
Okay, so first of all, for the wind industry had to mature its operation and maintenance earlier, because compared to PV systems, wind turbines are more mechanically complex, and they're often deployed in remote or high-risk environments. So unplanned failures are extremely expensive, and that's why the wind industry had to invest earlier in SCADA-based analytics or reliability modeling and structured maintenance approaches. And I would say that this is also evidence in the large number of publications from the wind operation and maintenance compared to the PV systems operation and maintenance. And I would say that the solar industry can learn several lessons from the wind industry. For example, the most important thing is collaboration. I can see a lot of collaboration between the industry and researchers in the wind industry, and open partnerships or data partnership as well. The use of digital twins, reliability modeling, and continuous feedback loops. So what I really see in the wind industry or the wind publications, that the operation and maintenance data from the wind systems are continuously being integrated back into the system themselves to validate, to plan, to design. So I think that if this has been followed in the solar industry itself, the learning curve will increase dramatically.
Okay, yeah, good. And so let's go into so there's different types of maintenance, as we know. So there's predictive maintenance, preventive maintenance, adaptive maintenance, prescriptive maintenance, and you've written about all of these, of course, in your paper. What are the most I suppose important methods to master? And I mean, does it depend on what a plant's individual needs are? I mean, I presume it also depends on where the plant is located, and what you're looking for out of this plant. I mean, everybody wants to make money.
Yeah. Okay, so I would say actually the selection of a right strategy, it depends on the plant itself. For example, small rooftop installations with limited monitoring systems, they can rely on simple preventive methods. However, large utility scale systems with rich data can support more advanced predictive and prescriptive maintenance approaches. But I personally think that the different maintenance strategies, they overlap. So they don't really exist in isolation. And the modern PV operation and maintenance is now moving towards an integrated, data-driven maintenance ecosystem where everything collaborates together.
Okay, and I suppose you recommend that people sort of go with the individual needs of their plant. Like you say, smaller plants maybe need a little bit less, and then so it really depends on balancing the investment and the gain.
Yeah,
I suppose if you're investing in technology, would that be fair to say? Yeah. Are you seeing any particular trends emerging, like technology trends, for maybe like digital twins for adaptive maintenance, for example, and or prescriptive maintenance? And are you seeing these trends emerging, and how might they impact the industry in the future as we go forward?
So after we published our review paper, we saw really an increased attention towards prescriptive maintenance, or what we call maintenance 5.0. So the PV industry, or till my research paper, we stopped at predictive maintenance, which is anticipating failures in advance. However, a new paradigm, which is prescriptive maintenance, it builds on predictive maintenance by recommending the optimal actions at the right time. So it can assist operators to know what to do, when to do it, and which resources to deploy. So I think this will really help operators to balance all resources, like efficiently prioritizing repairs, smart scheduling for the repairs, and also allocate the resources where they yield the highest impact. So I think this is the current trend, and it's a hot topic in the current literature as well.
Great. Yeah, good. And so I suppose for like specific technologies, are you seeing any specific moves, any specific interest in them?
Yeah, so two emerging technologies are actually receiving attention: digital twins and reinforcement learning. So digital, just to elaborate a bit. So digital twins, it assists operators to create a virtual replica of the plants, and it can continuously be updated with real data. And reinforcement learning is actually the AI algorithm that can be used to test different adaptive decisions. And both of them, they can assist operators in practicing adaptive decisions in a risk-free environment. So I would say these are the two emerging technologies.
Okay, and do you think that both of these technologies, digital twins and reinforcement learning and machine learning algorithms, do you think that they'll lead to more long-term secure strategies? Will they lead to? Are you already seeing that they're improving things on plants? Are you already seeing the benefits, or are these being tested yet?
Well, in the industry, I don't think that it has been tested fully, but they do start as decision support systems. So we are still keeping human in the loop. So operators, they do have the flexibility to refine, adjust, or validate the recommendations provided by these systems. So that's why I always think that the industry should be open to experimentation from us researchers, the algorithms, the technologies that we provide. And if both parties work together, I believe that we'll be seeing more of these technologies adopted in the industry.
Okay, great. And what are you working on at the moment, Hind?
So, Sorry.
Go ahead.
Okay, so actually we started to work with reinforcement learning for cleaning optimization. So we worked with predictive maintenance, and now, as I mentioned, as prescriptive maintenance is the newer paradigm. So we want to use reinforcement learning for adaptive cleaning decisions, because soiling is one of the main issues that we're facing here in the Middle East.
Okay. Yes. Yeah. That's very true. The Middle East has different needs on O&M for compared to Europe, which is quite interesting. And Hind, I mean, this has been a very interesting insight into the current and emerging research trends in PV operations and maintenance. And thank you very much for starting us off today and for helping us to explore them. And I'm gonna let you go, and I just want to wish you a very happy National Day, because today, December 2nd, is the UAE's national holiday. So I believe you're going off to celebrate that right now.
Yeah. Thank you so much. Thank you for having me.
Thank you very much. Thanks for joining us. That was Hind Abdullah, researcher at Khalifa University in the UAE. So thank you very much to Hind for joining us there. So Hind has contextualized some of the current and emerging applications for technology in operations and maintenance, and she's given us an indication of some of the problems and pain points those in the industry are facing. Now it's time to hear from some of the people addressing these needs, and I'm very grateful to our panel of industry guests who are joining us to share their perspectives. Just one moment. Okay, so we have, in no particular order, we have Werner Copier, CTO at 3EE, Dara Liu, CEO at LCOE.ai, Paul Fontaine, co-founder and CEO at Skyvisor, and Andreas Stordal, Vice President of Production Optimization at SCADA ASA. Thank you all for joining us. So Andreas, we'll go to you first if you're there. I just want to ask you a little bit. Hello, how are you? You're joining us from Oslo, I believe.
That's absolutely correct. I'm all good, thanks. Thanks a lot for having me.
Good. I wanted to start off with SCADA, their IPP and EPC, with operations all over the world. What are the main challenges and I suppose pain points in the industry at the moment, Andreas?
I think sort of the fundamentals of PV and renewable O&M and the sort of challenges we have there are quite similar to what they have been for quite a long time. Ultimately, right, sort of PV renewable O&M comes down to sort of three key aspects or sort of pillars, as we often refer to them, which is we need to keep our people and plants safe and the nature free from harm. We need to operate the asset in a way where we maximize the value generation, the revenue generation. Historically, that has often meant maximizing uptime, maximizing your performance ratio, your power curves of the wind turbines. There are some changes on that side, but I'll get back to that in a second. And lastly, of course, we need to do this in a way where we have a cost-efficient operation and do it at a cost level that is competitive. And as Hind has already mentioned, there's obviously been a substantial focus on this, particularly recent years. I'm glad to say that I sort of agree with Hind's evaluation that it seems fortunately sort of we bottomed out a bit in what was, I guess, effectively sort of a race to the bottom there for some time, and that we see sort of investors, partners, lenders also sort of gradually waking up, so to speak, to the value of good holistic quality O&M services. So while those sort of three pillars are quite the same as they have been, there's quite a lot of movement within those, so to speak, and where technology and new technologies are quite essential for how we're going about that as an O&M service provider. Firstly, there is a scalability challenge. Again, that isn't new per se, but it's one where I guess we could say, fortunately, from the PV industry side, it's just increasing in extent, right? Because we're deploying more and more plants. Many of the plants are just getting bigger, which means that we need to have digital tools and a digital sort of foundation which allows us to operate these plants in an effective way, where we can detect easily any anomalies that we would see, and leverage basically the economies of scale that you can get from those type of increasing portfolios and increasing plant sizes if you're doing it correctly. Lastly, however, to add to that challenge, we also need to scale now, let's say, an additional domain, which is the sort of multi-tech side of things, and where, of course, from Scatec side, for instance, we've gone in quite a few years from being predominantly an operator of PV assets to now operating also hybrid assets, BESS assets, etc., which means that also there's challenges coming that side, which we need to adapt to. Then, as I heard was a focus area of the webinar in this series from yesterday, there's sort of a transition where we're moving, you could say, from the focus on kilowatt hours to more energy services, right? And where historically we've had a quite strong focus from our partners on how we can maximize sort of uptime, maximum performance ratio. By all means, that focus is still there. However, we also now see an increased focus on sort of the predictability of this and the control of the energy, and where our partners are sort of challenging us on how can we also improve the forecasting side of the production, how can improve our sort of maintenance planning in a way where that also contributes to improving the revenue stream of the assets that we're operating. Lastly, as Hind has already also touched on, there is a big push within the space of automation and robotization, not at least. I mean, the use of drone for instance, thermography purposes has already been quite commonplace for a few years in the PV industry. However, we see now that the amount of use cases are increasing. Also, for instance, with the introduction of docked drone solution, where all of a sudden also security applications, ad hoc visual inspections, etc., are becoming really good technology enablers for providing efficient O&M services. And there's, of course, also within the space of robotization, module cleaning by use of robots, there's vegetation control, also ultimately even equipment inspections, etc., where there is technology emerging for doing that by use of robots. And then, well, we're still fortunate, I think, that at any given time in the PV industry in last years, a very big part of our total operational portfolio has been built through the last 1 or 2 or 3 years, simply by virtue of the significant growth that we've seen in that industry. Now, that being said, I think we and a lot of other operators as well are seeing an increasing part of our plants sort of becoming 10+ years in operation. And so we are working quite a bit from our side in making sure that these plants are sort of entering midlife gracefully, so to speak. That means that we sort of need to keep close eye on equipment health, condition monitoring, module health, and sort of degradation evolutions, etc., are quite key sort of focus areas of the module health programs that we have implemented at the plants that we operate. And I think also, as Hind touched on, while that, of course, is creating, let's say, some challenges we need to address, it also creates, we see some opportunities, because we have plants then which are out for a large part of their respective warranty periods, and which means that also there is a scope for adapting your maintenance program by using sort of reliability-centered maintenance methods, etc., to also, again, there address sort of the cost pillar side of things, which still continues, of course, to have very much focus, although in perhaps a more healthy way, I think, now than what was the case a few years back. There's many other things I think that are quite exciting moving in the technology space as well. But I will take a pause there, as I know that there's other panelists as well that are very much working with interesting and good solutions to some of these challenges and trends that I've been mentioning.
Thank you very much, Andreas, for that. Yes, and you mentioned drones and digital twins and AI and automation, which are all great. And we have other excellent panels as well to talk about those. So I will go to, because you mentioned drones, I will go to Paul Fontaine from Skyvisor. Thank you for joining us, Paul. I believe you're joining us from Paris. Is that right?
Yeah, that's correct. Thank you so much for having me. Thank you.
Yeah, good to see you. So Andreas mentioned a little bit about the new opportunities for drones, and I know that Skyvisor does thermal tomography monitoring, and you also do monitoring for inspections for solar park construction. But I want to talk to you a little bit about the I suppose how these tools are being used for on-site maintenance, inspections, routine maintenance. How are these being used right now? These drone solutions.
Yeah, well, drones have always been a fantastic tool, I would say. Unfortunately, not always making the headlines for the good reasons, but in the back office, it's definitely a very powerful solution that should be in every technician's or asset technician's toolbox, I would say. And as Andres mentioned already, it's been quite widely deployed. I would say there's a couple of reasons for that. Over the industry, it's always deployed in the wind industry. That has been mentioned as well a bit about by INT, I would say. And there's a couple of usages. The first one, most obvious one, is definitely the thermal inspections. That's been around for a couple of years. Now there is, of course, more inspections that can be carried out by drones. We've been talking about electroluminescence. That is a very specific type of inspection that we do to sample a couple of modules. And as Andres mentioned, now we are seeing more and more automation in this field using dock solutions. So basically, drone garages, I would say, that can cover very wide spaces of PV plants, but can also bring new applications like security applications, indeed, and construction monitoring, where we need a very high volume of inspection. Yes.
And this is, I mean, it's important, I suppose, for the construction monitoring to start from the beginning with these monitoring solutions. Start as you mean to go on, I suppose. And drone legislation is also becoming simpler. And we mentioned some of the headlines. We won't go into those. Drones flying over airports, but for solar, they can be good, which is important. But I suppose because there's also you can also automate your workflow once the raw data from the drone is fed into your app or whatever the case may be. So it's streamlining people's workflows, making it easier to have a sort of an eye over all of your different plants and scale, would you say?
Yeah, definitely. I mean, and drone has been evolving very fast. It's been following the trend of smartphones. So there's, I would say, two main factors that are bringing drones now in everyday all technicians' toolboxes. I would say the first one is legal aspect, as you've been mentioning. Now there is a unified European framework that enables all the different European countries to be following on the same framework, and that eases a lot the deployment of such solutions. So now the training lasts only about 2 hours. It's a free online test. And the second factor is the drone prices as well. That has been drastically dropping over the last years. So now a drone is going to be about 4,000 to 5,000 euros. So this is mostly for the legal aspect, but as you've been mentioning, indeed, there is the more operational view, and to make sure that everyone can do their own inspections, it requires indeed a lot of automation on site. So they will be leveraging on computer vision, on AI algorithm as well, to make sure that technicians can actually inspect whenever they need. And that's a very interesting part, I would say, of this kind of technology, that it can really be in-housed to leverage the full power and full potential of drones, because it's a fantastic tool that can scan extremely fast a PV plant, but this can be done so only if it's deployed at the right time. And deploying at the right time means having the drones always ready with you and not having to rely on to a third party and a subcontractor that, of course, needs and requires some authorization eventually, or even some travelers to come on site. So it really brings a lot of new applications, I would say, onto the maintenance spectra, like post-incident inspections, post-ailing inspections, for example, that before was very hard to conduct because all the different pilots and drones were busy flying. So right now, as you have it in your toolbox, as you could have a driller, for example, you can definitely use it whenever you need it the most. Yes.
Okay, thank you, Paul. Let's go to Werner next from 3E. Hello, Werner. How are you?
I'm great. Thank you.
Good. Thank you for joining us. I want to ask you because you have authored quite an interesting paper that I read before this session about digital twins. And Hind also mentioned digital twins earlier, and indeed they've already been mentioned a couple of times. Yes, I mean, just to get an insight from you, how are these solutions being used in the industry in Europe at the moment? How is this evolving?
Yeah. So if you look at digital twin technology, and I think Hint gave a very good, like of a definition of what it consists of. It means in practice that you structure your data, and that means data that you collect, but also the data that you produce with your assets over the lifetime of your assets, along in one structured information model. And this is one aspect of the digital twin. The other one is that it provides you a very good estimation of your expected behavior of your asset at all times. So these are the two phases of what we consider a good digital twin solution. And if we look into the practice of a PV asset lifetime, you start in your feasibility phase with performing your business modeling, creating your first business models, your first designs of your asset. You go into an engineering phase where you end up with a detailed design. You go into as-built information, commissioning information, trading information, because your asset will need to connect to the grid. You start to collect all of your monitoring data, and you want to make sure that all of these data sources, they become available in your workflows in a digital manner, and that you're not relying on tons of imports and exports from different software solutions in order to manipulate this data and to make this data available in your workflows and business processes. So this means that your financial modeling data, your engineering software, your drone inspection data, your field service management data, your monitoring platform, they all need to speak the same language. And that's a digital twin solution enables you to combine these across your workflows. So I do believe that digital twin solution as such it's not only about this aspect of interoperability, making sure that you talk the same language. It's of course very much about what you do with it and how that combination of data sources allows you to unlock analytics and to do better decision making, even when talking about very complex data manipulations. So improving your decision processes, both in the as an O&M, but as an IPP, or as a financial asset manager who needs to have a very good view on where your asset stands after 10 years versus your business plan, and whether it makes sense to start restructuring or not. So all of these aspects come into play, and going into that type of a prioritization of actions, and where you can really decide on yield improvements based on a return on investment, and taking preventive maintenance actions there is really key in the value that a digital twin solution can unlock.
Okay, yeah, thank you, Werner. Sorry, did you have anything to add there? Sorry,
and if we look to where we stand at the moment in our industry, I think it's good to reflect where we see, because we see best practices popping up and people starting to deploy digital twin solutions. Most of the O&M providers and best practices, we see that they're still getting stuck at normalizing their back structure and their monitoring data, which is of course important and fine, but this is the first step. You need to leverage that digital twin technology on top of that in order to create that interoperability and make your data work together.
Okay, thank you. And I know there's different types of digital twins as well. There's different models, but just before we get a little bit deeper into digital twins, I just want to go to Daryl first, because Daryl Liu from LCOE.ai, you're based in Georgia, is that right, in the US? So it's very early morning for you.
Yes, it's very early.
Good morning. Good morning.
But happy to be here.
Thank you for joining us. So I mean, like, you know, we all, like, we've heard here that the solar industry is very fast growing, competitive. In Germany, for example, it's been building out since the 2000s. But do you think that that the industry is now sort of playing catch up and forced to deal with the operational efficiencies? And LCOE helps. You're an expert in helping solar O&M professionals and EPCs make sense of their data with using technology automation tools. So do you find that they're struggling with like these and we've heard a little bit about kind of siloed data, poor maintenance strategies, difficulty scaling. So is it kind of has the industry come to a reckoning at this point? Is it at a turning point maybe where it needs to adopt more technology?
Yeah, I think that's where the industry is playing a little bit of catch up. I mean, I've worked in prior industries like large scale manufacturing and energy, and those industries are in a lot of ways still 10, 15 years ahead of where we are in PV, and especially in BESS. What I see also is, much to what Werner said, is that many organizations are still stuck really with a lot of muddied, siloed data. There's just a lot of noise, right? So a lot of folks are still trying to normalize the data. They're still trying to figure out what is their digital plan. And quite frankly, everyone talks about AI. So shouldn't we be doing AI? And so everyone just from the top down is saying, use AI. And so I'm hearing a lot of folks just saying, hey, so we have a strategic initiative right now for AI. It's like, great. What does that mean? They're like, we're still figuring that out, right? But they're just being told. And so there's just a lot of noise right now where, especially here in the US, where you've also had tax credits. Of course, here in the US, that's now going away. But there's been this huge momentum and push, just throw panels on roofs on the ground, and not a lot of real care to how is the asset really going to perform long term, right? Going back to even what some of the things Andreas talked about, right? There wasn't as much of the financial stewardship. It was more about, hey, how can we develop really quickly and let's move on to the next project, let's reap the tax credits, and the like. And I know that Europe is far more, it's much more evolved in many of these kind of circumstances, but we're still seeing a lot of these organizations with still siloed data messes. And a lot of those siloed data is also because most of these softwares have also in some cases fell backwards into success because they were born out of really mechanical engineers and electrical engineers who really needed some software to serve their purpose. And it just happened that, they talked to a few other folks that wanted to do it, and then they started launching software companies or whatever it is. And so they end up having all these different types of siloed technologies that are very much, in some cases, like Web 2.0, right? Mm-hmm. They're not really thinking about, whether it's API-driven architectures, interoperability. Struggling this morning. It's 5:38 a.m. So we're just seeing a lot of that. And again, a lot of the teams, a lot of organizations are just, they're still stuck in the muddy mess of their data and how to best leverage it, right? It's not just about, hey, great, I created this data lake, right? I'm using Snowflake, I'm using AWS, I'm using this. So what now? Everyone's trying to figure this out, but they're trying to effectively build the plane while they're already in the air. It's best to kind of really sit down and understand what are you really trying to achieve. And contrary to most folks, most organizations are not snowflakes. You're not really that special. There's very much things that you can learn from one another, and you don't have to always build from the ground up.
Okay, yeah. I suppose that's some good advice. Just not to throw everything not to just invest in a technology just because it's making headlines, but to actually reap the value from it is important. And I just for the PV industries specifically, how are you seeing? So you deal with O&M personnel, O&M staff, workers. How are you seeing them on the ground get the value from, you know, the data from the center, from the sensors, inverters, the SCADA systems, whatever tools they have? You know, how are you seeing them get results to ultimately, I suppose, you know, lower their LCOE and maximize their revenues, you know, boost the bottom line, I suppose, as it was?
Yeah, I see this in a couple different ways. I mean, like, so most of our customers are asset owners, your IPPs and in corporates. And then you also do have like those folks that are serving the O&M. O&Ms, these are also in some ways they're challenged in different ways. O&M providers, they typically have a much more of a smorgasbord of different data and systems because they're working with the client. So really it's about like how to also understand what's actually being presented to them and all the different noise that's happening. We find across the industry is that there's just a lot of noise that's being kicked off by all these different kind of monitoring systems. And so most folks end up being very much desensitized to what's really important, right? But also then when you need to couple that with some financial prioritization or even contractual obligations, that really helps them understand that when you really think about it, not every plant should be treated the same, right? Mm-hmm. There are different, not only contractual obligations, but there also could be a strategic account from an O&M perspective. Oh, I didn't even mean to do that.
It's okay, no worries. It's all live. It's fine. Don't worry about it.
I did not mean to just give myself a thumbs up. So anyways, you know, whether that's very much time savings, so they don't have to muck around trying to figure out of the 100 sites, what are the 10 sites that really matter? And then how do you drive those value back to the customer, which then at the end of the day, right, not only does that impact the O&M from new logos, but also renewals and recurring revenues from that perspective, right? But also on the IPP or asset owner side, they're ensuring that they are capturing or having the most reliable system as possible, and then able to obviously generate the highest returns that they can based on their models, right? So when they have portfolios, it's about how do you turn from more of a reactive and more into a predictive and more, even some cases, prescriptive.
Okay. Yeah. Thank you. Yeah, it's interesting to hear how this will evolve, and I suppose as the industry learns over time and becomes more mature, yeah, it will be certainly interesting. Werner, I might go back to you just about the digital twin. So just really quickly, I mean, can you explain the difference between physics-based digital twins and data-based digital twins, if it's not too complex to do in 1 or 2 minutes?
No, I should be able. Well,
okay, no worries.
Think of a data-driven digital twin as training a model based on your assets data, your monitoring data. So you will use AI technology, machine learning technology to create a model of your expected behavior of your asset based on your past data. If you look at the physics-based digital twin, then you should rather think of your engineering software. You know that in PV, software tools like PVSys are kind of industry standard. These type of engineering softwares, they're built out of physical formulas that define the expected behavior in the design phase under long-term weather conditions. What you do is, in fact, when you apply a physics-based digital twin, you will use the same physical formulas, but under the actual operating weather conditions or curtailment signals of your assets to create an expected behavior that is modeled in the same way as you did it in the design, as you did it in the design phase. This gives you as such a big advantage that if you consider a reference period from a statistical model, your PV asset is never behaving perfectly. So you will always have noise, imperfections, failures, underperformances that will be incorporated in your statistical data model that you would deliver. And moreover, you cannot apply it, for instance, during the commissioning phase of your asset because you don't have sufficient data. If you compare that to a physics-based digital twin, that is one where you use the same model as the one that you have been using in the business model. You use it as an absolute reference. So you don't look at historical data in order to train it, which means that you can really bridge it versus your business plan, and you can use it immediately. Moreover, we see what we do when we build out our solar analytics in order to do failure root cause detection and classification. We use a combination of this physics-based digital twin with your monitoring data. And then you're looking at failures not by looking at the noisy PV signals themselves, but by looking at the difference between your expected and your actual behavior. And that allows you to bring much more robust and much more reliable analytics in place in order to do yield improvement and create better business plans and long-term cash forecast for your assets.
Okay, thank you, Werner. Yeah, it's so it can these I suppose approaches can be tailored according to plants, and so yeah, that's good to hear. And digital twins is certainly a very interesting technology. It's still evolving, as Hind said earlier.
Sure.
And I'm sure you would agree. But I'll go to Paul then, just because Daryl, Andreas, and indeed Werner were talking about a little bit about best practices as well there, and I'm curious to know sort of what for the drone side of it, because drones are quite complex. What kind of training and onboarding and support frameworks are most effective, do you find, in equipping field teams field teams, O&M staff, to safely operate them and to capture the correct data, because it's specific inspection data. It's quite technical, and they have to think about photo quality, camera quality. They have a lot of things to think about. You can explain more than I can, I'm sure.
Definitely, and I couldn't agree more with what Daryl has been saying as well. There's a lot of noise everywhere in terms of the data quality, which is a key piece. If you have poor data in, you definitely get poor insights as well. So it's a key part, and in order to reduce this noise, but we strongly believe in as SCADA is to always keep the asset owners and technicians in the loop, because they are the one knowing their assets the most. And that's why for us, it really makes sense that those are the ones actually doing the maintenance, doing the inspections, because before maintaining, you need to understand what is the current status of your site and health status of your site. So that's why we're trying to equip them with the best available technology. And this is extremely simple to deploy, as we just mentioned before. Couple of hours of training. Drone tests are extremely simple. Drones are fully automated thanks to software like ours as well. And then this data can be fed into a more, I would say, general digital twin, like the ones developed by 3E. But still, I also agree with Werner in a way that next challenge is going to be interoperability, to make sure that all the different systems could talk to each other, starting with the designs. It's always extremely complex to get a design that could be exported to different systems from PVCs, but also from PVKs or any other software, and after get the most out of those designs to help asset owners take the good decision. Yes.
Okay, thank you, Paul. It's also and then I might go back to Andreas just really quickly to ask, now that you've heard all of these these use cases, and I'm sure you know them because you deal with a lot of plants at SCATEC, but and I'm not going to ask you what exactly you use, whether you use drones or or what combination, but I do want to know, is there anything that the industry overall can do to make your job easier, to make operations and maintenance at solar and indeed like hybrid solar storage plants easier, I suppose?
Yeah, thank you. And I think also would like to say well done and thank you to Werner for sort of breaking down the digital twin in such clear and not at least non-hyperbolic terms. I suspect sort of myself and Daryl might have found ourselves on some of the same seminars and webinars where this is sort of presented as some type of, I think was it data lake, AI-based driven witchcraft of sorts, right? Which isn't really the case. It's ultimately sort of down to breaking this down into sort of a clear data model, which enables you to detect anomalies, and whether that is sort of a database one or a physics-based one or a hybrid one for that matter. That is definitely something that is very relevant, but also where I think sometimes we're struggling a bit as an industry to sort of match the walk and the talk, so to speak, and to take it down to a level where we're discussing this in a bit clearer terms and what we want to achieve. In terms of what the industry could do, I mean, I think several of the other in the panel have also touched on that. I mean, we are an industry that is again coming from a very high focus on rapid build out, which in many ways is good, but that also means that we have at least historically been lagging a bit behind on even such a basic thing as sort of finding a fairly common terminology and nomenclature around how we talk about equipment, right? So that means that sort of when we speak to different providers, inverters, trackers, many of them have very different ways of talking about sort of same data points, etc., which in turn make that very critical part that we have discussed about standardizing your input and having a good basis and a good information model more complicated. I think it's also very important, as Daryl mentioned, to have something here which makes sense for those working in the part of the O&M space which is in the field, right, and on the plants, which after all is by far the most important, right? Seeing that those are the ones who can actually, in most cases, make a difference here in physical terms. And in fact, when we selected sort of a global maintenance management system for rollout around 5 years ago, one of the first criteria we put on the list is that this has to be a system that makes sense for those who are going to use it in the field, because we know both from our industry and from the others as well, if it doesn't, it's not going to be used, and the data quality is going to be horrendous, and people will start taking out sort of spare parts from stock without registering, etc. The second we've done there, I can also mention very briefly, is that we introduced around about the same time data quality KPIs, which has sort of worked quite well, at least in SCADA, for governing discussions about what we need from data quality, both in the maintenance management systems, but also in our sort of monitoring and analysis systems.
Okay, great, thank you. I'm just going to stop you there because we have on our next panel, we're going to talk a little bit about data quality and KPIs as well. So don't want to spoil too much for now. But I mean, I'm afraid we're going to have to leave it there for this discussion for today. But I mean, hopefully I'll be talking to you again at some stage soon, and I really appreciate you all four of you, Daryl, Werner, Paul, and Andreas. It was a pleasure to have this discussion with you, and it's gone far too fast. And thank you very much for answering the questions and for sharing your insights with us. And thank you very much. Appreciate it. Okay, now, so without further ado, we're going to move on to the next and final segment of the session. And I'm happy to welcome our next three guests, who are going to complement some of the points that we've heard already from our academic and industry speakers, and talk a little bit more generally about the importance of cybersecurity, maintaining quality in O&M standards, and strategies for leveraging data, as we heard there. You know, things like AI and IoT devices like drones, not just for smooth operations, but for operational excellence, for actually, you know, really going above and beyond. So in no particular order, I'm going to welcome our next three guests. I'm very happy to have them here. Fabian Michel, Head of Cybersecurity and Operational Technology at Belectric. You're very welcome, Fabian. Wojtek Kwiatkowski, Head of Solar Division at ABO Energy and Vice Chair of Solar Power Europe's Lifecycle Quality Workstream. A lot of roles there. And Manuel Lenas, Sales and Regional Director of Europe from DNV's Green Power Monitor business. You're all very welcome, gentlemen. Thank you for joining us. So Fabian, I might go to start with you first, because you're very knowledgeable on cybersecurity, and this is a very interesting and topical, important topic that we've seen recently, in particular with the Iberian blackout, some headlines with inverter issues, indeed. So I just want to ask sort of about the cultural attitudes maybe that you're seeing in the industry. I suppose in your experience dealing with cybersecurity issues faced by asset owners, do they have a good awareness of the consequences of not having good cybersecurity measures in place, do you think? Or is that changing now?
It depends a little bit on megawatt peak have in his portfolio and whether it falls under regulatory requirements. No? The larger customers from whom the topic of cybersecurity is very important and have PV systems equipped according to the current security standards. No? For customers who operate smaller plants, they're currently not the subject to any regulatory requirements. The situation is different. No? They have not really the pressure, I would say. No? We as an O&M service provider and operator of plants, we train awareness to our customers and explain the customers of smaller sites, for example, why it's important to use a next generation firewall or network segmentation. We also support our customers from the engineering phase onwards in implementing critical NIS2 requirements into the plant design as well. So it depends is the answer. We have two different types of customers in the end. Yeah.
Okay, yeah, thank you. And you mentioned EPCs there, and I know that Wojtek is from the EPC side of things. So I want to bring you in there, Wojtek, on the sort of how in your role you interact with cybersecurity professionals. Is I know that the cost sometimes can be quite high for cybersecurity services, but I mean, as Fabian would argue, I'm sure, and you would argue as well, possibly, I don't know, but depending on these headlines that we're seeing about cyber attacks, cybersecurity is a non-negotiable. But how are you seeing it in your field?
So thank you very much for having me, and best greetings to all the audience from Wiesbaden, headquarters of ABO Energy. Yeah, cybersecurity, a huge topic, not to answer in one sentence. Not only from European Commission point of view, not only from the Association Solar Power Europe point of view, but I think from all of us who are somehow in this industry, the cybersecurity is nothing and not something that investors should ignore for, in my opinion, two specific reasons. A hacker attack can trigger the plan to shut down and have a loss of revenue and even more. They can change the behavior of the plant and bring severe consequences. to the grid. So the severity of the attack can lead to a problem similar what we maybe remember what happens in Spain, Iberia last summer.
Yes, yeah.
And lead to a blackout. So it's really a huge problem. And for that reason, of course, everyone is aware that we have a war at the east part of the Europe, and this hybrid war could also affect our PV plants or hybrid plants or storages that we build and maintain. And that's why we put obviously more focus on that, and even not only on the association on national level to talk with whoever decide on programs to support the investment in cybersecurity. So it's starting to be not only our own problem, but this is starting on the national level be a problem of the national security. And that's why each program which is supporting such investments, even the programs which are coming from the defense programs of each national country, and could be beneficial to avoid such situation.
Yes, yeah, as we're seeing, yeah, energy is a vulnerable point and an attack point when it comes to international security, which is concerning, and also I mean, I suppose it's interesting as well. And I mean, Fabian, you were talking about a little bit about the sort of the cultural attitudes. I mean, well, not the cultural, but the industry attitudes to adopting cybersecurity. But I just want to ask you to expand a little bit more. How about like the small plants? Like, say, if you have, I don't know, a 50 megawatt solar plant in, say, I don't know, somewhere in Germany, we'll say, because Belectric, you're based in Germany, but with operations all over Europe and the world, indeed. But I just want to get a sense: are the small operators, are they aware of the scale of the vulnerabilities that Wojtek has just mentioned?
Yeah, it's also, as I said, it depends. Some of our customers are very aware of it, also for smaller sites, and are also happy that we inform them, and train them in awareness, and also how to implement, I would say, easy and cost-effective solutions to protect their sites better from the public-facing internet side. This is for me the important thing. We have to protect the smaller sites as well as the bigger ones. Yeah.
And are you seeing with your customers that that they I mean, that maybe they don't know? Are they maybe resistant because of costs? Are they saying, oh, you know, we don't need cybersecurity, or we don't need they maybe don't need to protect themselves?
It's mostly a cost-driven decision.
Okay.
Yeah. But if we explain why and how we can protect, I would say a baseline. Yeah, as I mentioned before, implement not only a 4 or 5G modem with a standard firewall. You can also implement a next-gen firewall to protect the site for advanced threats, for example, for internet attacks and so on. Yeah.
Okay, so you're saying a firewall is the particular firewall is the thing that it's kind of more of a best practice that you recommend.
It's a must-have. Yeah, it's a must-have.
Must-have. Okay,
Yeah.
Interesting.
From my perspective, yes, it's a must-have, and you cannot only deal with a standard firewall based on IPs and ports anymore.
So you can't have the standard. So what kind of firewall systems do most asset owners have already, and what should they have?
They should have a next generation firewall, as I said, with advanced threat protection, intrusion detection systems, and so on. We are also able to connect our SIEM solution. This is something what monitors the traffic of events. And behind that, there is a SOC with a 24/7 team that is looking for critical events, for example, and inform us if something happens on site.
Okay, so these these next generation firewalls can detect issues, vulnerabilities as they happen. But is there when the asset owner is actually I suppose setting up and deploying these firewalls, is there something that they should know, that is there an approach they should follow so that they get the maximum protection? Are these tools easy to use? Are they intuitive?
Well, if I understand your question right, you mean that our customers have a firewall and we show them how they can get protected better with the existing solution, or?
Yeah, just in general, I suppose, firewall technology, or how easy are they to figure out for like the standard? I mean, small plant owners may not necessarily have a big dedicated cybersecurity team.
Yes.
So
I explain it to them. The perimeter of a facility is physically protected by a fence, no? And only authorized people are permitted to pass through the gate on site. And the firewall is the same, yeah, with a correctly configured next-gen firewall and remote access via VPN. It's the same like a fence on site. And in this perspective, they understand it better what I mean. Yeah.
Okay. Yes, yeah. This analogy is it's a good analogy.
Yes.
Yeah. So I'm sure, and Wojtek, you would probably agree as well that cybersecurity is a must-have, and if you don't have these solutions deployed, you're at risk of losing a lot of money potentially, and as you said, the plant will shut down.
Yeah, absolutely. And we have some legal obligation coming from the CRITIS law, above a certain amount of megawatts installed, we have to apply such solutions, not only because the customers are requiring that and report frequently to the authorities. So what Fabian said is very important, but we think always internet, VPN and electronics and that, but also mechanical, barriers are part of such security measures. And of course, the access, remote control, and all what we can add, that some firmware will be not updated automatically. So just we cut internet connection to our inverters and not allowed to run any firm updates frequently. And this is what can happen if the grid or the PV plant is connected to the internet. But we have also to think that some ticking bombs, some temporary solution could provoke also problems. So we probably from the whiteware that after 1 day after the guarantee expired, some device can broken. And with this very frequently, that's exactly the same can happen with the all electrical devices what we installed. So this is not only about the updates or physical protections. This is also about time-related problems that could appear unexpected, and then very knowledgeable technicians have to go on site and solve such problems. So the cybersecurity is also a fast acting manpower on site to establish again the production of the PV plant.
Okay, yeah. So it's a zoomed out view and also a zoomed in view. So you have the firewall, but you also have I suppose the rapid response is another part of having good cybersecurity systems in place, and from the EPC perspective, I suppose, which is where you're coming from. But and also you mentioned components and equipment and inverters, particularly because they are a vulnerable point as well. Do you think like more needs to be done with manufacturers of these components, or is it from the EPC's sort of the beginning phase that you need to ensure that these components are all secure and that there's no vulnerabilities in them? It's something that you have to do at from the very outset, I suppose, that you have to have your best practices in place, I suppose. Would you say, because the life cycle of a plant is a very long time, so constantly updates, I'm sure. But yeah, yeah.
So let me start maybe from the beginning, from the EPC point of view. Once we select components, and of course they have to be safe, then of course we rely to the market standards, to the norms that are available. And what we see especially in our industry, very fast developing industry, that not always the standard like ICE follow the latest technological development. So here, therefore, the industry should rely not only on standards, but sometimes on guidelines. And here, where I would like to advertise a little bit for the work of Solar Power Europe, where we have developed with many very knowledgeable members our guidelines for EPC or O&M standards, which can be additionally taken into account in order to ensure the quality of the single components and later on of the execution of the PV plant. But sometimes this is even not enough, because the industry, especially hybridization or battery technology, is developing so fast and moving forward that even a very fragmented exchange with manufacturers and their best practices is needed to establish this best practice that we still try to aim and to share with each other. So this is how we do on a very early stage. And then, of course, during the execution of the plant and construction, there are a lot of tests confirming or even showing where are the vulnerability of the plant. And then if we enter to the O&M phases and have additional stress on the cost, because we shouldn't forget, Fabian already mentioned, very often investors are not really paying sufficient attention on maintenance and the fact that it should cost some money if the quality has to be provided. Then this is not easy. Then how to confirm or to convince investors to not save money in this O&M phase. This is the constant challenge we have if it comes to proper O&M service. But we reinforce this, saying that reliability of the assets and high performance of the assets, so more yield from the PV, it's very important. And of course, today with the quality and what we do, we can target 30 years and plus if it comes to the life cycle, because you ask for that, the whole life cycle of the plant. But I would like to make a disruptive question. Is this worth really to keep this long period of operational asset? Why? Because we see this fast developing industry, and we know, for example, if we take the modules, what happens with the efficiency of the modules in the last 10 years only. Somehow 2007 I started with 12% of the efficiency. Today we aiming 25, and this is the normal industry standard. So what will happen in the next 10 years in terms of efficiency, for example? And this could be the move towards repowering of the PV plants. So maybe not invest too much to keep those PV plants or hybrid plants longer at life, but think that each 10 or 20 years we have to repower them and gain more energy out of each such plant, and more efficiency, of course. And this will be maybe the right move to bring more return of investment for the owners.
Okay, yeah, thank you. And that's I suppose your disruptive point is well, you said it was disruptive. I don't know, but do we? I mean, I suppose Manuel and Fabian, feel free to chip in if you want to. I suppose really disagree or really agree with Wojtek's point on the repowering or the life cycle stage. I think I heard something there. Is that you, Fabian?
Yeah, I agree. And also during repowering, we also sometimes make a reconstruction, redesign of the network design, implement more security measures, and so on during this phase.
And just staying with you, Fabian, I know, Manuel, we're going to talk about reliability and data in a few minutes. You're being very patient there. Thank you. But I just want to finish the cybersecurity and component equipment side of things first. So Fabian, when you're looking at inverters, what kind of I suppose measures are you advising people, asset owners, to implement?
I think you mean the topic about Chinese inverters are maybe shut down remotely. You mean
yes, yeah,
right?
Exactly.
And
yeah.
which technology should we use? Well, I also can say what Wojtek said. We have to use components that fall under norms and compliance, also under Cyber Resilience Act. In the end, the customer could exchange the components by new devices from manufacturers that comply with that norms in the end. But this will normally only happen if the inverter is completely broken or whatever, and this happens, I don't know, every 15 or 20 years maybe. So it depends in the end on the customer side. If you want to have devices like that inside office plant. On the other hand, we protect and control the internet connection of these systems. So no inverter can communicate with the internet by default, for example, in our sites. There must be a reason for it. And we also look on the destinations and so on and so on. And in general, manipulations, e.g. undocumented communication units, are very difficult to find inside of a system. It's very difficult.
Okay, yeah. So it's, I mean, I suppose, you would possibly, it's, I suppose it really depends on all of the individual parts and plugging the gaps. It's like a cup of water. If it has a leak, then you're I suppose in trouble really. And also that nice fence analogy that you mentioned earlier with the firewall is also important. So yeah, it really, there's a lot of moving parts, I suppose, for people to consider and remember, and consistency is important. I'm sure you'd agree. Anyway, we might go to Manuel now to talk about data, and I suppose because you're with Green Power Monitor. They're based in Catalonia, and they're a part of DNV. So, I mean, Manuel, I might just start by asking you, because we've heard about monitoring and data and I suppose keeping a good bird's eye view on everything. But how do you ensure, because a lot of this technology is automated, how do you ensure that that your monitoring tools are up to par, are the best they can be? How do you monitor the monitoring technology that you have? For example, what are the best practices there?
Well,
Well, first of all, thank you for having me here.
Thank you for joining.
So on our side, it's a matter also being part of DNB, it's a matter of a constant audit of every single process that you have. Also, not only to data connected to cybersecurity, as the colleagues here in the panel, they were discussing, for us, it's a must, no? Constantly be auditing what you are doing through internal audits, external audits, at all the levels, on the quality of the processes that you are applying, and on the quality of your cybersecurity across the entire corporate, and in particular inside of GPN, no? So we cannot expose, let's say, our customers to any of these vulnerabilities that we've been discussing during the panel.
Yeah, definitely. It's important to I suppose to keep everything above board and to keep it tight and secure as well. That's a good point. Data also has to be secure as well. So I suppose we were also talking about artificial intelligence earlier, AI, and some panelists were saying that AI is it can be a buzzword, productivity buzzword, but it also does have its advantages and its applications, and I think you would agree for solar operations, maintenance, and monitoring, and to get a good overview of all of your different your assets. But is there anything that you think that O&M professionals and asset owners should consider before they invest in these artificial intelligence solutions as part of their operations, whether for monitoring or maintenance, or is there anything that you're seeing, possibly mistakes that people are making from your point of view, Manuel?
Yeah, sure. So regarding artificial intelligence, I always say that people talks about it as if it's an entity or something unknown, that it does magic. I just make questions and I get answers. But I always say that, so before starting on that, think that at the end, artificial intelligence, it's a complex program, but that it have huge requirements in order to work properly. Starting, for example, on the fact that if you don't have reliable data, all the analysis will be done on a bad start, let's say. So I always recommend them to start on seeing the possibility inside of their infrastructure to deploy all this, because it's not only a matter of having that data, it's also a matter of how this data is classified, it's tagged, what is the quality of the data. And once you know how your infrastructure is, you make some decisions, maybe investing on improving that infrastructure to be able to allow this artificial intelligence to take place in, then start making decisions. Okay, what is the outcome that I want to take on this? Like, not leave it as, oh, I'm going to put artificial intelligence as something that it will come and it will give me solutions. Also having a clear roadmap on what is the outcome I am trying to get out of this, no? And this is normally the discussion or the recommendation that I make to my customer.
So they're to use their personal intelligence as well as this artificial intelligence, and to make sure that they know what they're getting out of the investment as well, not just leave the AI to do everything, because that's not the way it works. But I'm interested to know about are these technologies, are they expensive and to implement? Because I know you mentioned that artificial intelligence methods like natural language processing, for example, they're being used by operations and maintenance personnel to sort of tag and single out individual data points, which sounds quite complex. Is that done on large plants only, or smaller plants, or how is this being used in the industry at the moment? Is it?
I would say that there is a little bit of everything, like in cybersecurity. You can start with just paying, for example, ChatGPT and trying to make some questions on there. or also you can establish plans where you connect all the data from your corporate, from your sites, in order to deploy this technology. So I think that there are solutions, and there must be solutions for everyone and for every single type of asset. Also, it's not the same if you have a single asset, like for example, in my rooftop, I have 25 kilowatt site. Maybe investing a lot, it doesn't make sense. But at the same time, we can have customers that have, I don't know, 2,000, 3,000 millions of rooftops. Well, millions not maybe, but a couple of rooftops where it makes sense to start incorporating this kind of solutions as do the size of the portfolio, but the small size of the asset, it makes sense to, let's say, invest in optimizing the operation of your portfolio.
Mm-hmm. And we're going to, I suppose, the data coming from devices like IoT devices, like satellite sensors, drones. Is there? I mean, you spoke a little bit about this, but how can operations and maintenance personnel ensure that this data is always reliable? Maybe Fabian and Wojtek might want to come in on this as well, but yeah, I'll let you go first, Manuel.
Well, on my opinion, like there is a sentence in Spanish that we say there is no 5 cents for 4 cents. So that means that at the end, the first thing starts on using a trusted partner, that someone that can give you some certificate in terms of ISOs and so on, and demonstrating to have, let's say, good procedures and good knowledge of the market that they are operating and the service that they are providing. At the end, I always say it's the same, like do not get surprised if the market, our market average is saying that something it costs 1,000 and you find it for 200. For me, it's obvious that you are not the smartest in the blog. Like you just, it will have some conditions on it. And as far as you know, and you assume the risk, for me, it's okay, no? But I always say, start making some kind of an audit and making sure that the provider that you have there, it really meets your expectations, and also it meets the expectations from the industry and from your own customer. At the end, here we have electric as O&M provider. They also need to understand, depending on the client that they have in front, some customers value certain things more, others they do not put that much in value. So you need to take also that decisions and based on that, provide the best solution that fits them.
Okay, yeah, thank you. And Wojtek or Fabian, do you want to come in on that point as well? I see Wojtek is not Wojtek.
If I'm allowed, I will start. So let me start with the components again. We spoke about this before. So the good quality of the components and services will lead always to good performance of the assets. And if you add the well-skilled maintenance workers with some very very good developed and very good integrated proper artificial intelligence tools, that this could of course fill the gap that the man cannot provide. So, but let me tell you also today there's a huge demand on cost saving if it comes to the maintenance, and the investors are really doing everything to reduce the OPEX. So another problem is we don't have enough specialized manpower, especially in Western European countries. So at the end, there's no way in this that we will avoid this way. So we must apply somehow to the automatization, to more sufficient tools, roboters, if it comes to the maintenance, and of course, everything steered somehow or supported at least from artificial intelligence. Today, we are bombed as a decision makers with several solutions from the IT industry, solutions which are more or less integrated into our systems in order to improve the predictive maintenance and to make everything what is needed, but not too much in order to save the costs. Hint Abdullah told us in the previous session already a lot about that. So I can only reconfirm that the human being should always at the end decide what is reasonable and what is really needed, but should evaluate all the tools that can help him during the daily work, and improve the quality of the maintenance, improve the quality and the performance of the plants and the assets. So there's no one answer, good or bad. It is something in between that we cannot avoid and we have to live with.
Yeah, absolutely. Yeah, the human intelligence is important, and definitely, yeah, it's going to be crucial as to how all of these technical applications develop as well. And you mentioned the skilled personnel as well, which is also a very interesting point that we don't have time to discuss today, unfortunately. But I do want to let Fabian come back in there. If did you have anything to add, Fabian, on Wojtek and Manuel's points there? Just before we...
Well, yes, what Wojtek said, we as human in the end should decide about the information which we gather out of the AI in the end. You can, or you should review it, and look into the data and said, okay, is this the reality or not? What AI is giving me as information, for example. And just to have a last sentence on the cybersecurity topic, I just only want to point out today that Electric have recently certified according to ISO 27001 and 27019 to make sure to our customers that what we say to them, they can trust in our security that we provide to the sites for them.
Okay, yeah, that's important too. I suppose the trust and the standards as well. Yeah. So that's good. That the certification has that people should look out for these certifications, and also the Solar Power Europe life cycle quality guidelines document as well. They should familiarize themselves with that, and the standards, industry standards across the board. Unfortunately, we're going to have to leave. The discussion today where we are, but because we've run over time. But we could go on discussing these points for a long time, and I want to thank you, the three of you, Wojtek, Fabian, and Manuel, very, very much for your contributions and for an engaging discussion. It was a pleasure talking to you all today. And that brings us all to the end of our session on O&M technology today. But I would strongly encourage those of you who are interested in project bankability and quality, also a very topical, important topic. So, if you're interested in that topic, please join the second Week Europe session today, hosted by my excellent colleague, Matthew Linus, a bit of a finance whiz, which kicks off at 3 p.m. CET. So you'll have time for lunch and everything. But yes, he'll be diving into quality bankability components that we've heard just now in this session. It was a little bit of a taster, hopefully. And the rest of PV Magazine's Week Europe sessions are happening tomorrow and Thursday, with tomorrow focusing on the latest innovations in cells and modules, and Thursday looking at all things energy storage. And as always, you can find out more details on the speakers and the lineups for those 4 sessions tomorrow and Thursday on our website. But for now, for me, and that's all. And thank you very much to our 8 wonderful guests for taking the time today to join us and share their insights and experiences in the industry. I really appreciate all of your contributions. It was a pleasure to work with you all. And thank you all also to our Week Europe series sponsors, our lead partner, Create Energy, our platinum partners, Hwasun, Jinko Solar, Shoals, Trina Solar, and our gold partners, Belectric, Intertech CEA, and Staubli. And my thanks also to my PV Magazine team colleagues for running the show behind the scenes. They've done a fantastic job. And finally, thank you to all of you in our audience out there who attended today for sparing the time. I hope you all got something out of it, and best wishes for 2026. Goodbye. Thank you very much.